Hi folks, Mr. Long here. Welcome to a screencast I'm going to make about the intersection of a line, y equals 2x minus 3, and a parabola, y equals x minus 4 squared minus 5. So to begin, let's sketch this line, 2x minus 3. Like, this is just rough sketch. So how I want you to begin every single problem is by making some connections to the graph, so that you know in the end that your answers are reasonable. So there will always be marks for your rough sketch. I mean, that's just the way it is. So let's go ahead and do that. Let's do a rough sketch here. So the first thing we're going to do is 2x minus 3. I know that the, y-intercept is negative 3. And I know it's sloping up. It's a positive slope, so it will look something like that. So there's our line 2x minus 3 has a slope of 2 over 1. Now I'm just going to go over here and I'm going to change the color for the other one. And let's see here. The parabola is x minus 4 squared minus 5 gives me a vertex at 4 comma negative 5. So out here at something like 4, right? A vertex of around 4. Again, it's a rough sketch. And then down here at negative 5, I don't really know where that is exactly, but something like here. So then I would go up within, draw a parabola like so, and like so, something like that. So I don't know, what would this intersection point be right here that I've highlighted? Well, that might be maybe 2, and this one might be, oh, I don't know, maybe 6 or 7. I'm not sure. But I know that one intersection point is going to be to the left of that vertex, and one intersection point is going to be the right of that vertex. Okay, that's the big idea there. One is to the left and one is to the right, but those are the intersection points. So let's go through the algebra. And I'm using a tool called Do to Math to show you all the algebra. And it's a lot easier for you to see this than to interpret my writing. So let's start with the parabola. And if we look at this y value here, it's equal to the y value here if and only if we're at the intersection points, right? So if I look, I'm just going to circle this in red. At that point right there, the y value on the line is the same as the y value on the parabola, which means 2x minus 3 is equal to x minus 4 squared minus 5. Okay, right there. And that's also true right there, but only at those two locations. So here's what we can do. We can actually take this, take this whole thing and bring it down. And look at this. I'm going to substitute in right there. So watch what happens here. That y gets replaced with 2x minus 3. Look at that. Now I've got an equation. And I'm just going to do a sketch of this just to show you what it looks like. So if we come over to the sketch, interestingly enough, I'm going to bring this sketch down here and I'll zoom in on it. So this looks just like my rough sketch, right? Look at that. There's the straight line. And if I look at this, oh, look. So it intersects at x equals 2. My rough sketch was pretty good, right? Now I can't see the other one. There's the other one right there. And it's at 8.32. So I'll double click on that again. 8.32. Now I said 6 or 7, but you can see that it's definitely a little bit to the left of the vertex and then one to the right of the vertex. Okay, so those are the answers I'm going to be working towards as I go through this. All right, so now we've seen a rough sketch. We know the answer. And let's see if we can do the algebra. So if I look at this right side here, what I've got to do in this right side right here is I've got to simplify that x minus 4 squared. So I need to expand that out. Okay, it's a perfect square. So I'll just double click on this and you can see what happens when you expand a perfect square. So you square the x, you get x squared. You square the 4, so you get 4 squared, and then you double the middle term. Okay, so you go negative 4 times x times 2, negative 8x. Okay, and now I need to do some simplifying. X squared can't be simplified because I don't know what x is yet. 4 squared can certainly be simplified. I just double click that, and 4 squared becomes 16. Do you see any like terms? Yeah, I think I do. 16 and negative 5. So I've taken that 16, take away 5 should be 11. Okay, so now if you look at this, we have a line on this side and a parabola on this side. Now I need to make it simpler by setting the left side or the right side equal to 0. So what I'm going to do is I'm going to take this 2x, I'm going to move it over here. It's not really moving, right? Like that's positive 2x. So what's the inverse of positive 2x? Negative 2x. But if I look at it, are those like terms, x squared and 2x? No. Are those like terms, negative 8x and, well, what is now negative 2x? Because remember, it's the opposite. Yes, they're like terms. So I can combine those. That becomes negative 10x. Okay, now I've still got negative 3 on this side. What's the inverse of negative 3? It's positive 3. So let's take positive 3. That's negative 3 on the left side. I add 3 to both sides, right? And that gives me 0. So are x squared and positive 3 like terms? No, and yes. 11 and plus 3 are like terms. So I add those. 14. Now it says something x1 and x2. That's interesting. So, well, I guess what I need to do is get out the old quadratic formula. So what I'm going to do is come over to here, and I think I've got a quadratic formula right here. So I'm going to take that and bring it out, and bring it all the way over to here. What I'll do is bring it over a little bit. Whoops, daisy. Bring it a little bit further over so it's easier to see. Okay, and let me come back to here. Oops. Gotta drag that to right here. Okay, and maybe make that a little bit smaller. There. So what I need to do is, if I look at this, what I need to do is figure out what B is, what A is, what B is, and what C is. So if I look at it, in this case, it's A x squared. So my A is the coefficient in front of the x squared, which is 1. B is a coefficient in front of x, which is negative 10. And C is the constant, plus 14. So let's just double tap on A, and A equals 1. And I hit OK. So now I've substituted 1. Okay, can you see that, folks? I've substituted 1. Now I need to substitute in B. And B equals, in this case, negative 10. I'm going to hit OK. And finally, C equals positive 14. Oh, I did want to show you something too. C is positive 14. Okay, there we go. So if you look at this now, I want to show you something. Look at my quadratic formula where it says b squared. Notice it puts it in brackets, in a parentheses. And that's because you have to square that negative, right? That always needs to go in brackets because it's not 10 squared and then make it negative. It's negative 10, then you square it. So negative 10 times negative 10, which is going to be a positive. So to simplify things here, I have to click on some things. So that multiplies those numbers out. Click on that. Square that, that's positive 100. Multiply that, that's 2 times 1, 2. And, oh, do I have some like terms there? Whoops. I guess I can double click on that, and that becomes root of 44. So those are my two answers now. 10 plus root 44 divided by 2, 10 minus root 44 divided by 2. And then I just need to do some more simplifying, turn that into a decimal, and then click on this and bring it up to here. Divide both of those out, and double click on that. 10 divided by 2 is 5, and this is going to be 3.317. There we go. So I've done that. Oh, sorry, if you can hear, I've got, you may hear dogs in the background here. I've got our older dog, our St. Bernard, and I've got a brand new puppy that is going to wake up shortly here. So I apologize if you hear any dogs barking or whimpering. Anyway, okay, let's go back to this. So those are our two answers for the intersection points. So 5 plus 3, 8.3. 5 minus 3.3, which is about 1.7. And I think if we're to bring in the answers here, we could see that, in fact, there's our one answer, 1.7, which is exactly that. I don't think this simplifies any third. Oh, it does do that. Oh, nice. So it will do that. So there's one answer, and 5 minus that is the other one. So look at this. 1.68 is one answer, and 8.32 is the other answer. So we've got it correct. What I'm going to do now is come over as a last step and just sort of summarize things. so that you can see all of the algebraic steps here. So first thing we did, folks, is